So in this video, now we are going to see fixed bias configuration. We already know that there are three types of configuration is there, like fixed bias configuration, collector to base bias configuration, and the voltage reverse bias configuration. In the three configurations, now we are going to see fixed bias configuration. Here, the term fixed bias, what is this meaning is nothing but here the resistor, base resistor RB is connected between the power supply and to the base of the transistor. Thus, this RB acts as a biasing resistor to the transistor. Here, the term bias is nothing but an external DC power supply will be given to the base of the transistor to make the transistor to operate in a particular region. We already know that there are three types of configurations or three types of operating regions are there, like active region, saturation region, and then cutoff region. Thus, by providing a fixed bias to the base of the transistor, now the transistor will be operated in a particular region. Therefore, its Q point, that is operating point, will be stable. Then here there is an input voltage is given to the base of the transistor. Then C1 is nothing but the input capacitor and C2 is nothing but output capacitor. Then there is an RC collector resistance and there will be an emitter resistance RE. Now in this configuration, now we are going to derive two main things. One is nothing but the operating point Q. Q is nothing but it's a function of VCC and IC. And also now we are going to find the stability factor. First, now we are going to apply the Kirchhoff's voltage law to its input loop. By applying the KVL to its input loop, now we will get the equation like VCC minus there is an RB resistor, therefore RB, then there will be IB current flowing in that resistor IB, VCC minus IB RB minus the base emitter voltage VBE equal to 0. See, now applying the KVL to its input loop, we will get the equation like this: VCC minus IB RB minus VBE equal to 0. In this, we can find either VCC or IB or RB. IB is equal to VCC minus VBE minus RB. I have already told that we are going to find the operating point Q. That operating point Q is the function of VCE comma IC. Therefore, now we are going to apply the KVL to its output loop. See, this is the basic circuit. Now we are going to apply the KVL to its output loop. Now applying the KVL to its output loop, we will get VCC minus ICRC minus VCE is equal to 0, like this. VCE minus ICRC is equal to 0. From this we can get the value of VCE like this. We already know that IC is nothing but beta into IB, where this beta is nothing but this beta will depend on the room temperature. That is, whenever the room temperature changes, the value of beta also changes. Therefore, when we find the stability factor for this fixed bias circuit, the stability will be directly depends upon the value of beta. Therefore, the room temperature gets varied frequently. Therefore, the value of beta also changes frequently. Hence, we can declare that this fixed bias configuration, its stability will be varies with respect to the room temperature. Hence, this fixed bias circuit is not recommended for the practical applications. But this designing of this circuit will be very simple due to its less complexity. But due to its poor stability factor value, this fixed bias circuit will not be recommended for the practical applications. Thank you.